Do you guys want a little bit longer, or should we?
No, go for it. Go.
2 seconds.
1,
1, 2.
2, go.
So the main thing you got to think of when you're solving this is that, again, work is equal to
Wait.
change in energy.
Sorry, I forgot something.
Okay. So if work is equal to change in energy, there's a lot of things that we can take into account here. We've got the work being done by the applied force, and we've got the work being done by friction.
Wait, question.
Yes.
3.25.
No.
1.78. No.
1.78.
1.79. No.
Okay.
I'd accept 1.79.
I didn't get that on that.
So the way that we work this then is this is our setup. So in order to go from here then, the work is going to be the work put into it, the applied force times distance, minus the work taken out, which would be your force of friction times distance. And to that we are going to set equal the kinetic energy. Everybody on the ship so far? Yeah, ships are cool.
There we go.
So, original velocity, as mentioned in the original information here, is equal to 0. So now we just got to plug everything into this equation and try and solve it for velocity. What I'm going to do, and what's a good habit for you guys to try and get in the habit of doing, even though it's oftentimes kind of cumbersome and intimidating, is to solve this for V before you throw the numbers in. Because as we go forward in this class and as we start doing more and more practicing for the actual AP test, whether or not you're taking it, they really like you to keep things in this form before throwing those numbers in. Sometimes they don't even give you numbers and they just want the general answer. So I'll just go ahead and do that then. So force of friction is mg, mu mg. So we've got applied force x.
Oh, I wonder if that's what it's called.
So I got to multiply both sides by 2, divide both sides by m.
Wait, I keep forgetting one thing.
Wouldn't it be?
And of course, in order to get rid of the square, we got to take the square root. And then you plug those numbers in.
1.78.
1.78 is right on the money.
I feel like it's easier to
I
remember
forgot
that
the stupid math.
instead of thinking just force, just think net force.
That works too.
I
Force applied
I
minus
actually
force of
did
friction.
that all right. I literally just forgot. Well, the first thing was I plugged it in and I forgot the distance when I multiplied by that. But then when I plugged in Fn for it, I only did 9.8 instead of 9.8 times 6.
Okay. So as long as you got it from here, you're in pretty good shape.
Wait.
Final questions on this one before we leap into one more thing? Sure.
Do the thing where you erase some of it.
Just erase one
Just
letter.
one streak through the whole thing. What?
What did I miss?
Nothing, just write it. Oh, you erased me.
What did I miss?
Oh my god.
All the numbers.
Erase all the operation signs.
That would get somewhere.
That would be terrible.
All the equal signs will be operation signs.
All the
Right.
subtraction.
That would be interesting to look at.
Throw a few integral symbols in there for fun.
Now we know he's just making stuff.
Yes.
What? Wait, what?
Don't overthink it, Potter.
What is that?
Wait, why are you writing everything?
Because he's being mean to me.
Did you get it all though?
What's
Yeah.
one?
Okay.
It's a
I got it
one.
all done.
Thought we were joking.
That's not a 1. It's obviously a half V.
When you get so advanced in math, you make up your own rules. And then you teach other people the rules that you made up. That's what he just did. He made it the half
That is honestly how math
He
works.
just
You don't think I know
He
it?
just taught us the half-ways.
That's right. When you become
Everything is equated. Just
Yeah, I was so good at asking, all you guys are.
an upper level science teacher, and no other teacher has you after me, I can just teach you whatever I want, and nobody's gonna call me out on it. So
That's what you always say. You
College emails you like, what do you teach a
teaching
student?
this class because no one in the school can correct me.
then I'd just say they were a poor student.
Sorry, they had a major.
Oh, they went to college. So we're gonna talk about power next.
College essays.
Thank you.
And of course, we got to deal with the calculus relationships
Power.
with power. I actually don't remember how the book and everybody lists power. It might be a capital P. I make my P's look kind of fancy there because we use P for a lot of different things in physics.
Wait, remember? Oh my goodness, what did you do? Potential energy.
Elongated the
Yes, the potential
So,
energy.
is
That's what you
power
did to it.
technically like the
Here.
integral?
What did I do with potential energy?
You made the P look weird. You
You accidentally wrote the P long.
Oh, yeah, that's right.
And you made it exact similar notes.
Yeah, that was totally on purpose. So power is equal to force times velocity. That's the easy one. Power is also equal to work divided by time. Power is also equal to the derivative of work with respect to time.
He doesn't do the consistency. What? Work over time.
Oh my gosh.
Did I miss something?
You just didn't do consistency. Your P's aren't the same.
Oh, right.
Oh, that's disgusting.
You gotta make it the PX because it's
Good.
There we go. You know, this looks like the symbol for your bright beams on your car.
Oh.
The high beams.
Wait, so it's work over time and the derivative of work over the or
What?
No, this is just derivative of work with respect to time.
yeah.
Yep.
What's FV?
Force
What's
and
in
velocity. Yep.
That's crazy how many people know about it.
So if power is equal to the derivative of work with respect to time, then you can tell pretty quickly that work is equal to the integral of power with respect to time. So make sure you're aware of that going both ways.
But work is the integral of force also.
It sure is.
We love when they yes, we love that.
Just skip stuff there.
The integral with respect to force is taken with respect to distance. So
Wait. So.
You don't have to write that word force. I just
So yeah, make sure you're aware of this. Work is equal to the integral of power with respect to time. It's also equal to the integral of force with respect to distance. So yeah, make sure you know which of those you're dealing with if it comes up where you've got one or the other. Questions on the math? All right, time to get in an elevator.
I was in an elevator today
What's
and
the
I thought
difference
about
between-
physics.
What's the difference
Elevator
between T,
jump.
P,
I was moving timpani, so I went up and down.
T, and F?
This is what they're taken with respect to. So when you're taking the integral of force, you're doing it with respect to x, so x would be like your variable if you're doing calculus. But if you're taking it with respect to time, t would be your variable. So it depends. It would become clear in the problem which one you'd have to do. You guys have been in the elevator in this building, right?
No. Yes.
Yeah.
Like, gosh.
That raggedy old elevator.
That thing looks...
It's really not. It's just that there's this covering over it. It looks fine underneath.
But with that covering, I mean, it looks like something out of an insane asylum from the 30s.
Yes.
It looks It's like one of those
Cushioning to protect the walls, which is exactly the same concept.
I suppose so.
Is it protecting the wall?
I don't know.
It's like one of those.
That's my guess.
Or is it because it's so shaky that it just makes to run to the wall?
We've got several children in the elevator here.
That one's me for sure.
That's
Mr. Hasway, you're recording, right?
Placido's
Yeah.
on top.
That's
Sorry.
fucked up.
Yeah, there's Placido.
That's me.
Katie's on the side, but Placido's all
I'm
That's
all
how
on
Katie
top.
would be sitting anyways.
over. Wait,
Wait,
why
wait
did
a
you draw
second.
Katie there too?
This one's wearing a top hat. Which one?
You drew Katie with the top hat too, because she would definitely be the one to wear the top hat. because
I
it
suppose
was-
so.
No,
Is
you
she
definitely
shorter?
said it because it was the shortest one.
No,
I was gonna
initially
say
yes.
that, then she beat me to the
Initially
joke.
yes,
was like,
I
oh,
did say it
man.
because it was the shortest one, but then he
That
added the top
was me.
hat.
No, because
We all know that one.
Katie would be like hanging upside down from
Where's
her
the
leg.
guy floating? That'd be me.
This is Ben and this is Jaden with the obscenely long arms doing a pull-up competition.
I don't mess with no one anymore.
No, I did
Not
say
even gravity.
That's a pull-up competition.
I did say it because it was the shortest one, but then he added the top
If I
hat,
can
and
use my
come to
legs,
agree that would make it even more of you.
Like,
Did we get everyone in there yet?
Well,
think
we
need
got
to
what,
label
10?
all of us.
1, 2, 3, 4, 5, 6, 7. There's 8 in here, including
There's
the.
8.
Yeah, 8 in the classroom.
What are two
Placido,
There we
Katie,
go.
and Ben. Yeah, 2 of them are Katie.
We need one more.
Well, Kylie and Ender are virtually in the elevator. So we'll put.
In the pocket of the
Draw a screen.
Mr.
Draw-
Hasway,
You got This is a little laptop.
That doesn't look socially distant.
Drawing it.
Oh man.
When they ask for this, he just shows them that picture.
Ah. Alright, great. Then he's like, figure it out.
Once we're done, I want you to
Figure
have
out who's
faces
who, huh?
and
Yes.
Figure
I will.
I'm outside.
We'll expand on this later on. That'll be the last 10 minutes of class.
We have to
Are we
go
gonna have
over
the master?
these.
We're gonna see exactly what we all weigh here. So why am I not in here yet?
Draw yourself like a.
Make
I'm
sure
the
you're-
floating
You're
one.
the elevator. No, you're the
You're the elevator
elevator.
conductor.
I'm the conductor.
No,
Okay.
you're
No,
the elevator.
make
Those
it
were like the
make it a
tension
box
boards.
that you're shaking
It's
up
the
and down.
magic spool.
Draw yourself.
Can you
like
be
a-
pulling the elevator up?
Elevator.
Can you be pulling it
Like
up?
you climbed out of that secret hatch. from
Oh
the top.
yeah. Yeah, I'm up top.
Yeah.
And I have a monocle.
What? That's not fair.
I was gonna say you have the light that has the Batman symbol on it. shining
Wasn't
inside.
this guy? Wasn't this your normal physics too?
Not quite.
Whoa!
Me?
Ours was kind of boring.
How
It was-
it was Mr. Hathaway, how dare you allow that to happen?
What's going on? I wasn't listening.
Nothing.
They said that their regular physics wasn't this exciting, and I'm like, ours was.
Oh, well, the classroom. I think Katie was part of a subdued physics class, I think, right?
Which
Katie,
came in my
which was
class.
physics?
I don't know. What?
Were you in my physics? With me and Potter and Tinder?
My physics consisted of Savella talking to me the entire time and me yelling at her the entire time.
I think
Yeah,
second
yeah, I know,
semester
I
I
know.
was by.
Well, I had Joey
Kylie.
Amicus and Carlos, so that
Kind
alone.
of in my class.
And then we had, did we have Brad?
Because we would sit
Linsky?
somewhere up front.
Or did we have Brad?
I feel like
I
that
think we had
was.
Brad.
Oh yeah, and I helped you with the graphs all the time.
Ben doesn't need help ever.
I don't remember that. I feel like that's someone else. But
No, that was
okay.
definitely you because then you go, oh.
Okay, so we need to figure out what the power is
Oh, that one side.
required to lift this elevator.
Out of like 20 graphs.
So if we're going to solve for power here, we've got information about velocity. We've got all sorts of force information up there. So probably our best bet is this guy. Power is equal to force times velocity. Now the real question here is, what does this force stand for?
Net force.
Good guess, but no.
No,
This is the one time where it actually doesn't stand for that.
So
Uh,
it doesn't stand for net force?
Well, you need net force in order to figure it out. But if we're looking for the power required to lift this elevator, we got to concern ourselves with the force that's actually in play when it's lifting the elevator.
So it's
Gravity.
just the sum of gravity and friction. Is that what you
Yeah, it's your tension force, which would be the sum of those two things. So this is your tension force here, in this case. Because this is the force that is in play as it's lifting the elevator. that force is what goes in this spot of the equation. So, force equation time, right? So tension minus the combination of these two things. Acceleration is 0 because we've got a constant velocity, and you eventually find your way to the answer. Bless you.
People always sneeze in threes.
What is my, how do I find my force of gravity here?
9
Bless
points.
you.
Mass.
Total sum of the mass.
MG.
Wait, are we including people in the elevator at this time? Or no?
What?
Are we including people
Yes.
in the elevator? for this?
Yeah, the whole
So you
thing.
have to do
The sum of
add
masses
mass of
times
the
G.
elevator and the mass of the people.
Right. Yeah, you got to make sure you're adding all that together. So it's
Wait,
going to
are we
be
all 100 kilograms?
1,800 times 9.8 plus the force of friction, which is 4,000. And out of that magical equation, you're going to end up with 21,640 newtons. So that would be your tension force. So in order to figure out what your power is, you got to take that number and then just plop it in right here. And of course your velocity finds its way there.
Oh, that is. No. I did the calculations and we all weigh about 88.88 kilograms, so that's like 195
So what does that
I
stand
think I qualify as like 2 of them.
What does that stand for? Newtons times meters per second?
Power is measured in watts, actually. So when we do this multiplication, we end up with, let's see, 64,900. I gotta start making these P's more fancy again. Oh, that is a pretty good looking letter P right there.
I like the P over to the left where you wrote the force power equals force times velocity.
Oh, this one?
Yeah.
That's a good one. That is a good one.
I laughed when you were writing 21,640 because your 4 definitely started as a 2.
It does,
Didn't you
doesn't
just say 40 and then you added the stick and I'm like, oh.
216 squared.
Isn't that like hold on. Isn't that like the sine of
No.
Jupiter?
Yeah,
Well,
kind
it's
of.
like-
It does kind of look like it, doesn't it?
Do you
Why is it 9?
what's that one have you ever seen that game where it's like how many numbers can you find in this and it's like you have the 2, you have the 4, you have the 1.
Oh, yeah.
Yeah, it's 21.
So, any questions on how this works? We're gonna take this to another level then.
Are we adding?
Can we go back down to the
acceleration
first floor?
Sure. We'll head back down to the first floor.
That's all. You forgot that in the elevator, you forgot the thing that tells you, like, the buttons you press, and then it tells you what floor you're on.
Yeah. Yeah, I better put that in by, who's got the top hat? Is that Katie?
Yeah.
Yeah,
I'm also the one on the wall, I think, so.
No, that's that is Potter.
Oh, that's Katie.
Oh, I don't want to be on the wall.
I would definitely be the one to be both.
On the wall? Where?
On the
Yeah, Potter would be the
Sideways
one.
one.
Potter would be the one by the computer.
You'd be trying to actually
Yeah,
get something
I'll be the
done.
one with my computer. I'll be the.
I'm
I'll be
next
the
to
top
Katie.
line down.
I'm next
I'm
to
the
top
top
hat
left.
Katie trying to take her
Lots of
top
us.
hat
See, everyone
that
would do
she's
it.
short.
That's always
Let's
The
go
top hat
recreate
makes
this
her
picture
as
no
tall
more.
as me.
Not even Brandon.
So
Yeah, I think we need to recreate this picture.
So this is going to be the same scenario, except
We're gonna glue Katie to the side.
Except there's no gravity.
v no longer equals 3 meters per second.
Ah,
Equals
so
4.
It equals 4.
It's a no longer equal to 3, then it's 4.
Oh no!
And then we'll do 5. And then
What?
6.
I don't know if I can
I
handle
know how
that.
to change that. I know how to get that one.
Alright. So now we're going to say our acceleration is 1 meter
Then you
per
have to
second
use that to
squared.
find velocity.
Can we just take the integral? Or what is it? Isn't it?
I don't think so.
How it,
We would have to get a function.
Ah, yeah.
So we start with the force equation.
Yep, we're going to start with a force equation just like before.
I have to find acceleration.
And again, power is force times velocity. And once again, we need this force to be tension force. So that's something that we got to calculate.
Is it the same?
Could be.
If you never plugged in velocity to that equation, so it's still be 21.
That's true.
Oh wait, it said you said it equal to math. Oh. Never mind.
Yeah, never mind.
Yeah, never mind.
Okay.
So in this equation now, it is a little bit different because instead of setting our acceleration equal to 0, we have it equal to 1. So we got to solve for that tension force. And it's going to be a little bit bigger because now we're accelerating upwards.
What's the mass? Which one are we using for the mass?
You add them together.
So 1800.
Yeah.
Yep, 1800.
This is a big number.
Modest clothing for today? Or
This is a huge number.
Yeah, so that's our equation if you wanted to do it that way. If you wanted to, you could factor out your m's.
I got 23,440.
23,440.
We don't need.
That is correct.
Eagle is 440. Yeah, Mr. Huckler, can I use the blue?
Absolutely.
But you have to find velocity.
Stop that beater. We have them.
Maybe just take this out.
We don't.
Oh, we don't have them. So we have to.
Look like a girl rolling into the.
So if we know this is our tension force, we could plug it back into the F.
Oh, we need
Exactly.
velocity.
We don't have our velocity, so what we would have then is a function
To find
of
velocity.
power with respect to velocity. So we could find our power given any velocity
So-
number.
So we're gonna
We don't
we
have
can
a
write
timer
something
or
like
velocity or anything like that.
Right, right. So if it actually gave us, like, if we're accelerating, if we really wanted to, we could say 1 meter per second squared, how fast are we going after 4 seconds? And then put that specific velocity in this equation. I think you guys are good enough with that, though, that we don't need to run through that exercise.
so how do we show for the answer?
It would just be 23,440 V.
That's it.
So yeah, I think that's about as far as we need to go with this. Final questions?
Can you continue drawing?
Yes.
What's the
part
test?
B of the test.
Oh, the number 6.
B.
I'd rather talk about
Oh yeah, let's do that for sure. I better turn off the recording for that one.